The Arleigh Burke Aegis-class destroyer. She's one of the most advanced warships ever built. And yet, for all her high technology and sophisticated weaponry, this modern wonder wouldn't exist but for the sweat and skill of a dedicated team of shipbuilders. Here at the mouth of Maine's Kennebec River, along this rocky coast steeped in maritime tradition, lies Bath Iron Works, where a century of shipbuilding excellence meets the very latest in innovation.
We did the first Arleigh Burke destroyer using paper and pencil on ink and mylar, doing it like my grandfather used to do it. We took what we had on the mylar and on the drawings, and we built computer models with them. And now those computer models are the way we do it. It's all done with the computer. In design, we've broken the ship into 70 or so different units with many compartments. Each unit is built kind of individually, and at the end, we put them all together. Each destroyer is unique in itself. It may be 95% like the one before it, but it's not exactly. It takes about 6 to 9 months to actually build one of the destroyers.
Data in the designer's computer is transmitted to the production floor, where the virtual will now be made real. Regardless of how it's designed, every destroyer begins its life when virgin steel meets the fire of the cutting torch.
We're cutting 2.5-inch HY80 with this steel. Once I dial it down, I program it in. I set up my torches, different size tips with different size metal. This is all programmed. Once it's programmed in, it's all automated so that it has its own guidance.
Thousands of pieces of precision-cut steel will be carefully shaped and joined together to build the 70 hull sections. For all Bath Iron Works' advanced technology, a destroyer is still largely handcrafted. It takes 6,200 tons of steel shapes to build an Arleigh Burke. They all have to fit together perfectly, and the success of the ship is totally dependent on the skill of the craftsmen who build her.
This is called a penetration ring. It's a flat oval. Because of the fact that I probably would break the pin because of the pressure it takes to make that small diameter, is the reason I do it hot.
This penetration ring and others like it will form the pathways for the 1.3 million feet of cable and wiring that will run through the ship. A team of welders work the production floor, joining individual pieces into simple sub-assemblies. The intense heat generated during welding can warp steel. In a manufacturing process as precise as this one, the distorted sub-assemblies have to be straightened before they can move on down the line. The most common method employs a 500-ton press to force the often stubborn steel back into shape.
Sometimes the press can stretch the material, and sometimes we have to use heat to shrink it. We heat the steel up, it expands, and if we can restrict it from expanding, it'll cool slower than it was to begin with. So I can put the pressure on it to keep the plate from rising up when I heat it, and it can only shrink down when the material contracts. After heating this up, it'll take 2 or 3 times probably to get that panel flat, but a little bit at a time, and eventually the whole edge will look set flat and straight like it was designed to be to begin with.
And where heat in the press won't work, a more human approach is called for.
Well, what we're doing is trying to straighten these edges of these pieces. When they welded them, they distorted.
About the only way we can straighten them. They tried to do it on the press, but where it's set at an angle, they were worried it might launch it out the side of the press where they actually shot it. So
we're doing it the old-fashioned way.
We'll kind of do it the old-fashioned way. See how good a shape you're in, I guess. We'll be huffing and wheezing before it's over, but it's about the only way to get the job done.
Further down the line, another team of craftsmen work on larger units.
This area here is where we do most of our flat panels, decks. So what happens here, they'll in turn butt these plates together, then they're processed down the line where the ship fitters, which you can see up there, assemble the bars to the flat panel, then in turn gets transferred further down where they do some automated welding on the stiffeners. You can see he's got the automated welder going. He's welding both sides of the stiffener at the same time, which obviously is very productive as well as the quality of the weld. This particular section here, I believe, is a deck section.
Finished sub-assemblies and deck panels are welded together into ever larger units. The bare bones of the ship are beginning to take shape. It takes months to go from cut steel to finished hull section. But finally, the 70 hull sections that once only existed inside a computer are taking shape on the shop floor. Each of these enormous modules is known as a superlift, and each superlift is completed to the highest degree possible. Lighting, piping, electrical conduits, even furniture and fixtures are installed now, before these building blocks come together as a ship. As the structural work is completed on each hull section, workers ready the superlift for its specialized equipment. This hull section will be home to one of the ship's 3 generators. Before this crucial component can be installed, a team of riggers roll the 350-ton module outside, bringing the superlift within reach of the shipyard's 100-ton crane. This generator will supply the ship and its weapon systems with electrical power. Though as big as a truck and weighing over 30 tons, it's still a precision piece of machinery. A team of experienced riggers carefully guides it into place.
This way.
We're going to have to.
Keep eye on our chimps.
Yeah.
Before we finalize it.
Got plenty of room on that side. Just going to miss this right here.
As long as the bull drag, but they might.
No, they won't. Have faith. Done a hell of a job.
Oh, yeah.
Under the watchful eyes of his riggers, the crane operator high above carefully lowers the generator into the bay. And then a problem is discovered.
Yeah, thing's sticking off.
All metal bracket is in the way.
You don't got any room down there. If you go to drive, you're going to hit your shims because that's you got about just enough room for that.
So we need to cut out.
All right.
We believe we need a ship fitter up here to cut something off so we can land this.
Yeah, if the other one was not.
Thank you.
The multi-million-dollar generator must wait, while the ship fitter struggles to cut away a $2 piece of steel.
Bring it down a little bit. Looks good.
Yeah, coming down nice and easy, bud. You'll see how the bolts line up the hole.
Once they start in, we'll do it. I think we're in.
Okay.
With the generator in place, work on this section of the ship is finished. After 2 years, the destroyer's final form is emerging as completed hull sections are joined together piece by piece. Superlift units are so heavy, they require both of the shipyard's largest cranes to lift. These lifts are typically scheduled at night to minimize impact on the yard's workflow.
We are picking a unit up to get ready to put it on the ship. Weighs approximately 355 ton. And it'll take about 8 to 10 hours to do the process, to marry them up together.
As the cranes take up the weight, welders burn off the temporary support struts. "40 minutes later, the freed Superlift is ready to go. 355 tons of steel are hoisted aloft.
Both cranes stop, traveling. Both cranes coming down together. Both cranes coming down together.
The real test for modular construction is when each Superlift is mated to the ship. Every component, bulkhead, passage, pipe, and conduit must line up exactly.
We have to bring her down a little bit, travel, again, bring her down, try to get a level as much as we can as possible to put everything up. How are we looking on them tubes? Are we hitting anywhere around there?
Yeah, on the starboard tube, she's hitting hard on the top side of the tube. She's got to drop down. She's like rubbing hard against it, so when you drop it down, we got plenty of room all the way around.
All right, Warren, coming down easy, coming down easy. Okay.
Coming down easy. Held that. This is what you want to happen. Keep it going.
Will you hit somewhere up there, Mike?
Now go ahead and come down a little bit more.
All right, Warren, coming down easy again, please. All that. Do we have a gap on the top side?
We got about a quarter of an inch opening now. It's looking good.
We're about an inch open on the bottom. That's as close as we could get it with the cranes now. So now they got to put chain lug-alls onto this unit and try to pull it over with 6-ton lug-alls.
Work continues through the night. By morning, the riggers have made everything ready for the day shift. The hull section has been jacked into place and tack welded. And while the job seems close to finished from the outside, inside, an army of welders are just getting started.
Every square inch of this gets welded, whether it's all the structure and or the ventilation in the overhead or the piping everywhere, everything gets welded. So there's a huge amount of welding. And there's always call for more welders. You can never get enough of them.
With the Superlift resting on its keel blocks, the cranes pull away. The destroyer has grown a full 60 feet during the night, one hull section closer to completion. Months later, All 70 superlift sections have been pieced together, and the distinctive lines of the Aegis-class destroyer are apparent. But while the ship may appear close to completion, she's still little more than an anonymous hull. There are many major components yet to be installed, including the destroyer's missile system. This is one of the ship's vertical launch system clusters. Each Aegis destroyer has 8, housing a total of 64 missiles.
On my way. Consists of my 2 riggers and myself. Hands-on knowledge. I just kind of move the levers. Once we hook them, they have to, and a lot of the stuff is
Mr. Moody, coming down about 4 or 5 inches.
coming down.
Okay, you should stop losing weight, Pudge. Keep on coming down. And hold that. How much you losing, Pudge?
I'm down to 8.5 ton right now.
All right, let's hold that.
This is the floating dry dock. Finished ships are rolled into the dock. The dock will then move out into the Kennebec River and submerge, lowering the destroyer gently into the water. Until recently, ships were built here on these inclined ways and launched with an uncontrolled slide into the river, a potentially hazardous process that has capsized many a vessel.
The incline ways does date back to the Phoenician days. On an incline launch, it was restricted because of weight. You could only have a certain amount of load on an incline before you were forced to put your ship in the water for final outfitting. With this process, we're actually physically going to lift the ship 6 inches, and then by the propelled cars will transfer into the dock.
While the concept may seem simple, actually moving an 8,500-ton warship into the dry dock is a complicated task, especially considering this is only the shipyard's second transfer. Positioning is critical, as the tracks on the land and the tracks on the dry dock must line up precisely. It's the job of the control room team to coax the dock exactly into place.
We don't need to run both of them.
What we got to do this morning is to align the dock. We'll bring the dock up a few inches and we'll pull the dock one way or another with the surveyors on the land until we put it on 0 center line. And here we have a camera system that we're able to monitor when we come into this position. We refer to these as V-guides. There's a piece on the dry dock and a piece on the land, and what we're trying to do is come into that wedge, or what's called a V-guide, and that will position us each time for the rail system.
Fractions of an inch matter, and a surveyor confirms that the alignment is accurate.
bow is holding at 1/32 port. Stern is about 1/2 inch starboard. One-inch port, center line, 1-inch starboard. Good.
Secured. All pumps secured.
With the dock in final position, it is carefully lowered until it rests firmly on an underwater concrete grid. It's finally time to get underway. Hydraulic rams lift the 8,500-ton ship.
All clear at the bow, Jeff Neal.
Get on the way.
We're moving, right? We're moving. That's a whopping 6 feet per minute. Have they put it in high gear yet? That's it.
Tensions rise as the ship approaches the connecting rails. A problem here could easily mean disaster. The transfer takes just over 3 hours. An uncontrolled slide down the ways has been replaced by a precision move.
The translation went flawlessly. And what we're doing now is we're connecting the services to the ship. Production will start on at approximately 11 o'clock. We'll start blasting the hull of the ship, giving it a paint job. All the lessons learned from our previous experience have paid off in this, and it went outstanding.
3 weeks later, the destroyer has received her coat of paint and is ready to get her feet wet.
We've just started the ship up on generator power, and the ship now is basically running itself as far as temporary services. We're actually taking that equipment and placing it on the ship and without loss of power internal to the hull as we continue building for the ship today. So that right now that is probably the last critical step that we have to put in place in order to make the ship, prepare the ship to go into the water tonight.
The transfer into the river is dependent on the tides, and the shipyard crew races to prepare for tonight's float-off. The sun has set and the tide is rising. The time has come to put the ship into the water.
You don't have any spare people up here, do you, Darren?
No, I got 3 with me.
Alrighty.
We're in the process of commencing deballasting to get the dry dock off the grid. In a few minutes, we'll actually be free from the grid. We'll lift up approximately 12 inches off the grid, and then we'll pull back approximately 20 feet.
Massive chains pull the dry dock into the river. In order for the dock to sink deep enough, a special submergence hole has been dug into the river bottom.
Right now we've centered ourselves over the submergence hull and we've begun flooding the dock. Once the water scale, we'll start our watertight integrity inspections on the ship. That's to ensure that there's no leakage or flooding on the ship. This is the first time the vessel has ever entered the water, so we have people manned all the spaces on the ship checking for watertight integrity. Chuck, you see any line movement yet?
We can edit that.
I think my number one line there. His line, moving back out here too.
Roger. Ship's afloat. Ship's afloat.
Whenever you're ready, Chuck.
Roger that. Coming up, Sean. You guys ready? Just touch it easy.
It's going to come to you because we're bringing it to us before we let it go.
Touch her up, Sean.
The destroyer is hauled clear of its cradle to the port side of the dry dock.
Coming up. Good.
Using tugs and winches, the crew gently backs their new destroyer into the river.
Kenny, back ahead to clutch. Darren's, hold it. Slow her down. Slow her down a little.
A temporary skid holds the ship a safe distance from the dry dock wall.
Okay, Darren, slack off a little. Not get her going too fast. Leave that head half.
Free of her tether, the tugs maneuver the new destroyer to the outfitting pier.
Tugs.
Christening Day, a transition point in the destroyer's life. Her Navy crew is finally meeting their new ship. With the newly christened destroyer docked at the shipyard's pier, the crew joins the builders to complete final outfitting.
When we got here, it was nothing but metal, and now everything's coming together, paint, all our parts, and our crew's coming together. Everybody's getting to know each other.
Big bad truth.
It's different from going and living in a bed to living in a rack, but I'm enjoying it.
We moved aboard about a week ago, sir? Right?
Well, our official move date was Wednesday.
Wednesday.
So it's been an interesting few days. Very stressful, but...
Finding the burning space was an important part. Moved all of our mattresses on board, got all of our racks loaded out with our personal stuff and our uniforms. And then in the shop, we received our tri-walls. They're craned onto the ship. We got to load them box by box and load them into the spaces that they belong.
We've been moving, I'd say about 40 boxes of supplies every day. This will be one of our spaces. I think we have 9 ETs working out of this one little space here. It's going to be a little bit packed in here, but this is it.
Being in a hotel was great. I mean, it was, you know, it's a hotel room. It's large. You have a lot of room and things like that, but it was very difficult not having a place to. So we can set our stuff, we can get our pictures of our family up, we can get our, you know, our things that make it feel a little more like home.
Now we're eating 3 meals a day on board. We're doing laundry on board. We're, you know, dispersing is paying our paychecks and all those things that we were doing in the building and relying on, in some ways, on civilians to help us with. Now we're doing all by ourselves.
This has been the toughest 2 weeks in the Navy of my life, but I think it'll be worth it once we go to sea.
Those tough 2 weeks and the weeks to follow are the last sprint to the finish line. But completing the ship is not the final challenge her builders or crew will face. It's time for sea trials. 4 arduous years of labor have gone into her. Now it's time to see whether or not the destroyer operates as promised.
Shafts will be rotating in approximately 5 minutes.
Well, I'm Commander John Ailes, and I'm the prospective commanding officer of this ship, and we're about to head to sea for the very first time. We'll be out for 4 days, and each day is jam-packed with test after test after test in a comprehensive schedule designed so that in those 4 days, when we come back, we are fully tested, and we understand that the ship is operating as it was designed.
A cloud of white smoke indicates that the engines have come to life, ready to move the destroyer for the first time.
Both shafts on the line. We have bridge control and ready to answer all bells. Ready to answer all bells. Very good.
Captain Earl Walker is the ship's civilian river pilot. He knows the Kennebec like no other. His job is to guide the ship safely out to sea.
Okay, full touch stop. Full touch back easy.
The Kennebec is a treacherous river, and the 10 miles from the Bath Iron Works to open sea is a labyrinth. Worse, the destroyer is so large and heavy that in some places, clearance between hull and river bottom will be measured in inches.
The Kennebec is quite a tricky river because there are numerous cross currents and eddies. It's very narrow, and the worst part is its bottom and banks are very unforgiving. It's granite, so we have to stay in the channel, mind our speed, mind our courses, and if we do that correctly, we make a safe transit.
Navigators triangulate off known landmarks to plot their exact position, as have generations of shipbuilders and sailors who have come before them.
Navigation holds you 75 yards left to track.
5 yards, time to turn. 1-4, 2-4. Recommend coming right to new course 184 to regain track.
Fort Popham has guarded the mouth of the Kennebec since the Civil War. It marks the place where river meets sea. Passing it, the destroyer finally moves out into her element. Sea trials get underway with a test of the ship's propulsion plant. Here in the engine control room, the builders and crew gear up to put the destroyer through her paces.
We have control fuel pumps, pretty much there, right? Seawater cooling pumps, hydraulic pumps, throttles, lube oil pumps, engines. It's all right here.
It's the first time that I've seen the engines up and running, seeing the shaft turning this speed, because we can't attain that speed at the dockside, so it's kind of good. It's rewarding. This is the rewarding part of the whole trial for me.
It's a pretty amazing thing, because you can't relate to what's going on outside, but you can feel it shake, you can feel it shimmy. You can look up at the speed meter and it's like, my God, we got, what, 8,500 tons? And all of a sudden, we're going places in a hurry. It's kind of neat.
Four 27,000 horsepower jet engines feed into the main reduction gear, the ship's transmission that transfers power from the high-speed engines through these massive shafts to the low-speed, high-torque propellers. For the first time, the destroyer is allowed to strut her stuff. A 4-hour run at 50% power is a prudent warm-up for her impressive abilities.
We're going to do a gear inspection on the port reduction gear as we run that 50% run to break it in and to show a wear pattern on the teeth. We've cut back on the port shaft, bringing it to a stop, and still maintaining 10 knot headway with the starboard shaft, just increasing speed on that.
Ports are opened on the main reduction gear, and factory technicians jack the gear into position for inspection.
Right now, General Electric, along with the Navy representative and BIW, are inspecting the reduction gear tooth patterns. General Electric assesses the tooth patterns and gives us the verification that we're safe to proceed to full power.
That's Dykem that you're looking at. The red and the blue material on the gears is a Dykem. It's a lacquer-based paint, so to speak. As the gears mesh, the Dykem wears off, and that's what we're looking at, the contact pattern between the elements. We're looking for a nice uniform contact. Otherwise, we'll have to make a bearing correction to get contact.
The technicians keep a careful record of each inspection.
Lighter on the red. Right. The red on the low speeds is coming a lot better. Right. Full.
The reduction gear ports are closed and sealed. Sam prowls the destroyer's engine room. His instincts tell him that something's wrong. Sam's hunch is proven right. There's a problem with one of the propeller shaft seals.
The shaft seal is where the shaft penetrates to the underwater hull. And this thing is designed so that you have a rubbing effect to seal almost like the water pump in your car. You see how large it is? And right now we've got a misalignment issue where it wobbles a little bit and we're getting a little more leakage than we're supposed to. So we're documenting it. The yard who does the work is going to try adjusting it to see if we can adjust it out underway.
Zero in the middle of the suite. A little wobble to it, so the only way to dial it in is to jack the shaft around slowly, put a dial indicator on it, and straighten it out as you go around, jacking it around.
The final day of sea trials is reserved for the ship's 100% power run. In anticipation of this important test, Sam Petty continues his hunt for gremlins. First stop, the main reduction gear. Also high on his list, the recently adjusted shaft seal.
Sam, that's the leak. It's better. It's within the specs with a 100-hour wearing period. And they pulled a wobble out of there that they've had.
With everything checking out, the destroyer is now ready for her ultimate test. It's time to up to full power.
All right, 89. Go up to 90 and stay there. Great. 90. Right. They give us permission right now to go to 110. I'm just going to go until our pumps cycle off here. Build up that speed very slowly. Lower bump off. Yeah. Build up slow. Kind of watch your parameters. Keep an eye on that loop ball header pressure. We have to make any adjustments.
We're slowly building up to 168 shaft turns. We're at 114 now. These are on up. It's our first big date.
Doing fine. Looks like it's coming up good. You notice how you feel it vibrate now? You can feel the power hitting in the hull.
Right now we're doing the full power run, which is a 4-hour elapsed test to make sure that the engines, transmission, everything is working efficiently within parameters that can sustain it at 100% power, max speed. The idea is to test the system as thoroughly as possible to make sure that the ship can drive for long periods of time at full power. And there are times when we do go full power. Previous ships I've been on 3 days full power to get to a place where command authority needed us.
Sea trials are a success. This ocean-going thoroughbred is ready to join the fleet. The long labors of the men and women of Bath Iron Works have paid off, and handsomely. Their newest ship has been put to the test and has met all challenges.
We see the ship being built at Bath Iron Works over a long period of time. We see all the pieces of it go together. And it's just an exciting thing to be a part of it, to go on trials, to take her out to sea for the first time, and to demonstrate that the ship works, not just the first time, but every time, over and over again.
What began as raw steel under the cutting torch has been transformed by fire, sweat, and the shipwright's skill into a fully functional warship. The Navy's newest Aegis-class destroyer carries on a proud tradition. She's a modern engineering marvel, a noble heir to 100 years of shipbuilding heritage.
This is the culmination for some of us, 2 years of work. It's a beautiful day, and I can see the ocean.
Coming up next, experience the drama of the front lines through the eyes of those who were there on back-to-back episodes of Fields of Armor. Next on the Military Channel.